SynMax Competition Racing Motor Oil 15W50. Now, this product is normally used where extreme heat conditions or racing and heavy duty engineering specifications requiring a 050, 550, 1550, or 20W50 motor oil. Very good for hydraulic lifter performance. Now, what's in this? Well, it's an extreme duty racing formulation, including full synthetic with Aerospace Base Oils, the Polyx Premium Viscosity Stabilization formulation, Tackifer, which allows the oil when it's cold to crawl and stay upon the metal surfaces, then when it's hot, increases polarization. Now that draws the oils and the additives to the micron metal surfaces of the components to embed them deep in. It has diamond-like additives providing maximum anti-wear protection with the lowest coefficient of friction available. High zinc with at least 1,500 parts per million, including ZDDP and synthetic zinc, which is double to triple that of your modern street oils. Superior protection for the valve train, for the camshaft, cam bearings, the flat tappet, solid lifter, roller lifter, hydraulic lifter, and all the needle bearings that are within it. Very good protection for the piston and piston wrist pin area, including the skirt protection and increasing the skirt to cylinder wall performance. This is a professional off-road use only product and is not designed for modern API street requirements. For more product information, check out the SynMax videos and presentations. On this specific product, please review or download the brochure, technical data sheet, and MSDS documents. To find out how the Aerospace Advantage for Motorsports through diamond-like additives, providing the lowest coefficient of friction with the maximum protection in rolling and sliding applications, that is to follow. Here we go. This was a solid lifter metal surface, okay? And it's going to show fretting on the left versus pretty much brand new. Now, what happened was both of these motors were run with 520 or 530 oil, I'm not sure, a NASCAR engine, okay? We're talking like, it was actually a 800 horse engine. It was a dyno run. And so it simulated in the dyno for 600 miles or 700 miles of operation. But here's what happened. On the left, the lifter on the left had micro fitting on the surface wear. Now this was from frictional heat. Okay, you see the crown that was there? You see where the cam would stroke on the side, then it would hit the crown, then it would come off of the lifter. Now, that's similar to a piston crown, and that's called fire flash degradation. All right? And then on the right, you see the oil with the Polyx technology and the DLA technology. This lifter was like brand new. You say, does that make a difference? Well, we've got guys in short track racing that run about anywhere from 800 to 1,000 miles a year, and they're on their third year on their lifters. So the oil almost paid for the lifter. The cam's $1,500 and the lifters are $500. You're buying technology. You're not just buying a bottle with a label. All right. Now you can see the lifter on the right, the DLA additive allowed the surface to operate cooler with greater protection. How's that evident? Watch this. Now this is very interesting. Here's 50 times magnification of the lifters. Now, the lifter on the left has what we call microfretting surface wear. It's from frictional heat or heat oxidation, which means thermal breakdown of the metal surface. Similar to a piston crown, the terminology is called fire flash degradation. What's actually happening is that these lifters are very expensive metal machining to get them to the point to handle what they do. I mean, you can see the machining scars that they do, and the reason they have those machining scars, like on the right, is so that those cross hatches are able to hold the oil, and then the oil that's held is supposed to protect that surface. So the additive package on the left obviously was not sufficient enough to do it. I might say, Clayton, I know what it is. You must have had your 1,500 points high zinc on the right, not high zinc on the left. That is not true. Both of these had a racing additive package. The one on the left and the one on the right. They had the same amount of zinc, I'll tell you that right now. But the one on the right also had an aerospace synthetic zinc along with it for higher temperatures to run cooler. The one on the left would have had moly, probably 1,000 parts of moly and maybe 13 to 1,500 parts of zinc. The lifter on the right would have had the diamond-like additive package, the synthetic zinc, and multiplied together, it was over the 1,500. But this showed additive technology at the subsurface level, all right? Because obviously something worked on the right. Now here you're going to see the metal fretting coming through. Now we're not coming against any company, but if these were your lifters, you really couldn't reuse the ones on the left, but you could reuse the ones on the right. Again, the lifter on the left, you could see where the metal started getting hot, it was exposing, it was opening up, and as the cam struck across it, it started to break off the metal. On the right, the additive technology, the Aerospace Advantage, was able to stay in the metal and not allow it to break. The picture says it all right there. Here's an engine that was a super late model motor designed for the CRA series rules. It's a 358 V8 9-to-1 compression, and this is what we call a 4-barrel 390 carburetor motor. But with a special design, it's able to do 9,400 RPMs at 550 horsepower. Here's the deal. This is the camshaft. Now, there's two types of areas that we have on here. After 1,000 racing miles, the cam is still like brand new. You can look at the rollers, and it's like it wasn't even used. Furthermore, you can look at the slide areas of the roller lifters in the slide areas where they go in the engine. They're not even barely touched. So this can be reused. You might say, Clayton, but I always thought on a camshaft it was on a solid lifter. Now we're going to get into that in a minute, in the presentation. But we also have to remember the little needle bearings and how much punishment that they go through as well. This is DLA technology in action. Another very important area is the piston skirt and the rod bearings. Okay, this is after 1,000 miles. Look at this skirt. It's like brand new. It's like it was never used. Why is that, Clayton? It's because the diamond-like additive technology got into this skirt and it just protected it. 9,400 RPMs, that's a long time. Now, I know these bearings are coated here, but you can see they're like brand new and literally could be reused again if the engine builder would choose to do that. So here we've got a graft, and it took a lot of money and time to make this. But over here you've got your Molly B denims, organo mollies. These are the products that most of your race oils are going to be, or performance oils are going to be making out of. You know, whether it's Mobil or Schaefer's or others, they're going to be using some moly in their oil. Royal Purple, uh, Joe Gibbs. Yet over here, we've got the Polyex. Okay, so when they had like a wear scar testing, all right, it was a Phalanx pin V block test for 1 hour with 500 pounds of load on it. Okay, the SynMax provided with the Polyex 58% more protection with less additive package used. Amazing. The other thing that's interesting is there's 3 diamond carbonates inside of the diamond like additives, which is basically for cold, medium, and then extreme duty conditions. It takes a little bit of time for them to soak in, about an hour. Once they finally soak in, you can see here in these cycles that in seconds of time down below, all right, that the coefficient of friction lowered to 0.14 coefficient, and that's pretty low. Moly is around 0.9. Now, the following presentation is to provide data as supplied by Aeromotive Research, and it's the testing wear differences between moly and other additives. The other thing is to show the low coefficient of friction, and then also we're going to talk about combustion deposit cleanliness, which is very important at your higher RPMs. And then last, you're going to see a flat Tappet performance um, with a moly high zinc oil versus the advanced technology that the SynMax, the Diamond Like Additives, and Polyex is able to do. Now we're going to talk about what we call combustion chamber cleanliness. That is very important for long-term, sustained, high RPM needs, or also in your automotive applications in your street car. You know, you have to keep your combustion clean. Anytime that you've got a computerized situation with fuel injection and timing and sensors, you have to keep it clean. Because if the racing additive package is overtreated in the oil, it will create piston hotspots, causing spark plug contamination and detonation. It will. But the DLA Polyex nanotechnology provides clean combustion operations. Now, here was a test that was conducted. Again, we had moly and other types of moly. And then on the bottom on the right, that means a base oil with no additive at all. So what happened was is when we had molybdenum, there was like 50 milligrams of deposit in the combustion chamber. When we had Polyex, all right, we had like 30 milligrams of deposit in the combustion chamber. About 45% less contaminants. Why? Because it was a cleaner additive package. Now this translates to cleaner and more efficient combustion chamber operations. All right. So when you're running 9,000 RPMs, screaming along, or Formula One, whatever they're doing, you're going to need all the help that you can get.